All right, so make sure you have posted in the discussion board just to try to help. I put in here that this is the scrambled 15-word assignment, should be week 12. That's the one you should be posting into the discussion board. So hopefully you can find some help for other people, give them some advice, try things out, see what other people did. Now, what I have done in the assignment folder, so assignment folder for week 12, I put a couple of samples up that you can download. And so I'm going to keep that one, and I'm going to go back and grab the other one, and I'll show you a couple of samples of some interesting code. Get back to downloads. So one of the things we want to think about is making life easier so that I can take whatever program it is and I can expand on it. We call that ability to scale, so that you can grow a program, you can change a program really easily, you can use pieces over again. And one of the ideas that came out of last week's chapter is that idea of using menus. And so both of the examples I have in here, we've taken that menu structure, literally just utilized it from some code base we already had. And so this particular example says welcome to the word list and has several pieces of items in there. So home, window, closet, chair. The words don't really matter that much. You can put anything in there. But then it has a menu that says exit, display list, add a word, or scramble the list. So they separated all of the functions. So if I run this particular piece of code, I get a very clean display. It says, do I want to exit, display list, add a word, scramble the list? Well, I want to look at the list first, and I want to make sure that that list really did scramble, so I can look at the original list, and I can say, oh, well, it's not scrambled, so let me make sure I scramble it. And then it re-scrambles it, and we can actually look at that code and what's going on there. So the next piece then is we want to add a word. So we add a word. What word would you like to add? And if I try to add roof, which is already in the list, it should error out and say that word's already in the list and kick you back out of that menu. So this sample A here that I have just really has a set of if statements. So if choice equals 0, then you're going to print by and you're out of there. We have a show list, which really just says if it's 1, you're going to print the list. Now, there are more elegant ways to print that list. You could do a for loop and print that from top to bottom, so it looks a little more elegant. Your scramble here, they found that they could use the random.shuffle words list. That actually does a really nice job. There are other ways, and a lot of you found other ways to do it by trying to scramble it by using getting the length of the array and going through there and using variables. But this is probably the simplest way to randomize that list that you have in there. So this was a really quick, clean, easy way to do it. So I also have, and this one just has a little more humor in it. So this one has a very similar type of structure. Again, we use that basis of this menu, and so it's a great structure for that. They ask for some very similar structure. So I'm going to run this one. And so this one asks, all right, do I want to list words? Yes. And notice we listed it now vertically. And so we did that with just a really quick for loop. And you can do that. So if we want to add a word, so we can add a word, and in this case they even added the ability to remove a word. So pick a choice and you can actually remove it. So This one went just a little bit beyond and added that delete function. And then it has an error trapping routine at the bottom. So take a look at those when you're also looking at your own code. And these I kind of cleaned up. They're fairly clean. I don't have a ton of stuff in them. The other piece that you should have on these, make sure that you have your name, because once again I had people who didn't put their name in there. And make sure you have this function at the bottom where you end or you come out of your function. So some way that it's clean. So check your code. Try different things in it. And try those. So these are a couple of samples, and I posted those right there in week. Still running. So I posted those in week 12, so you can take a look at those. Come back to week 12. All right, so samples down at the bottom. Those are kind of interesting to look at. And that menu structure is kind of a nice way to wrap up some of our real quick code. That way you and everybody else can understand what's going, and you can put it in those blocks. Those blocks lead to the idea of those functions. So your menu, maybe each item on your menu creates a function. So I'm going to start on page 178, and we're going to create a tic-tac-toe program. So let me get my stuff organized here really quickly. All right, open up this. And again, this entire set of code, is available in course documents. So if you get lost, you want to grab it, you can certainly do that. I'm going to start up idle. And I'm going to get into my script mode, so I'm going to do a file new. Of course, it always wants to pop on the other window. And so I'm going to put in some information. So who I am, this is tic-tac-toe. And remember, these are free to use. You can use as many comments as you want. It doesn't hurt to use them. So on the top of page 178, we kind of looked through the pseudocode. So if you go back to 176, you can see kind of our pseudocode, what we're going to do. So we know that we're going to have some of these functions, and we know kind of how we're going to break this program down a little bit. So the first thing we're going to do is we're going to set up some constants. So we know some things are not going to change, or at least we're going to not change them. And we're going to call those even global constants, because we're going to use them throughout the program. And so the first one we're going to say is x equals, here's a surprise, x. So we can use that to print out the x on our sheet. And we're going to say O is equal to the character string O. And empty, that we're going to use later, is going to be equal to a blank character, or an empty character. Tie is going to be equal to tie. And number squares is going to equal 9. So 3 times 3 is hopefully 9. So now we're going to go down and we're going to create our main function. And so I'm going to go a little out of order in here, but I want to go in and I want to create the main function so we see where that actually starts at. So normally, so now we're going to have some functions. So functions. And then we're going to have the main. And so the main, and this is a pretty common tactic we do, all that we're going to do in the main is we're going to launch the main function. And then we're going to put in a default input. Press the enter key. So our main program we've already built. It's already there. That's all it is. So if it's going to run, then we need to come back up and we need to look at our list of functions. And so writing those out on a sheet of paper, kind of planning, is really a good idea. And so for us, the author has set this up and has put all these instructions and what their functions are on table 6.1 on page 177. So we have the display, we have the ask number, we have a new board, and so we have all these different functions and we have them defined for us. So in the book, we start going through and we set up some of these. So the instructions are one of the first things that we're going to do. So we're going to create the instructions. And so in this case, it's called display underscore function or instructions. As long as I keep the same name, it'll be fine. So again, I look at my list and I go, that's what I need to do. And so anything in this code block that's indented is going to be part of that display instructions. So to save some time, I'm going to grab this function piece out of that existing code base because it's a big triple quoted string and I don't want to have to try to retype that up here on the fuzzy monitor. So it literally says, here we are, welcome to the greatest game. You could change this up to your heart's content. It's only going to run when we call that function display instruction. So our main function hasn't yet been even decided what we're going to do with that. So the other piece we've done a lot is we ask yes or no questions. And so this should be kind of in our code bank already of what things do I need to have existing. And so you can build your own little code bank and things like this yes or no function, because we do tend to use that over and over again in programming. Now we have a yes or no question. So this is one we've built before. Nothing different about it. We know we need to call it, and we send a question in. It asks yes or no and returns a response. So one of the other ones, though, we need to ask a number. And so that number is going to be within a range. So you want to ask between what cell or what dot, because we don't have yet the touchscreen figured out for this game. We need to figure out what cell you're going to place an X or an O, depending on if you're the computer or the player. And so we're going to create a function that will do that. So we're going to use the define, and we're going to call it ask number. And so this one's going to take in a question. So you're going to be able to put in a text item, but it's also going to take in two more variables. So it's going to take in low and high. So you can use this to ask a question about any kind of math number. So it might be useful in other games or other structures you create. So you're going to send in, you need a number between low and high. And we set low to 0 and high to 8 in this case for the most part. So we can use our triple quote in here so we can identify what this function does. And so this is going to ask for a number within a range you send to the function. So that triple quote piece doesn't print in this case, but it does allow you to give a title to each function to make life easier. You can also go ahead and even put in comments. So note this takes 3 parameters. You could put in defaults for those, so you could make it more robust, but we don't need to necessarily do that. So the first thing we're going to do is response. We're just going to use the same format we have up here. So in fact, I'm just going to copy and paste it, because that's the greatest thing. In this class, we actually get to copy and paste, and it's a good thing. So we'll response equals none. So while response not in range low, high. So in other words, we're checking to see if our answer is in there. We don't actually have an input yet. So this is always going to evaluate the first time to actually loop through. So we're kind of cheating that priming the pump issue, and then response equals, and because we want a number, we have to use that integer function of input question that we send into it. Make sure we have both parentheses, and then this is going to return response. So that lets us ask a number and from a question. So we can send any question to it, and we can send any numbers. So it's kind of a handy item to have in our list. Well, our next function we're going to look at is the pieces function. And the pieces function, so this asks the player, do you want to go first? Or do you want to let the human or the computer go first? Now, what we're really doing is setting up which player gets the X, which person gets the O. And kind of the common thing that we've always done with tic-tac-toe is the X goes first. So we're going to define a function we're going to call pieces. And notice it doesn't take in any data, so there's no parameters going into it. And again, we can use that triple quote, determines who goes first. So we're going to actually create something called go first. And we're going to actually call a function from within a function. So we're going to use the ask yes or no function. And so we're going to pass into it that question, do you want the first move? So this will pass into our question here, and then it'll return a response back. And that response here, that return response, becomes the value for go first. There we go. All right. And so now we can do some more with it. We can look at, so if go first is equal to yes. So in other words, you said, yes, I do want to go first. Then we're going to set human equal to X and computer equal to O. And you could put in all kinds of things. So in our book, it actually puts in print, you will need help. You are going to lose, human. So you can put in snarky responses or whatever it is you want to put in there. But what this does is just determine whether you have the X or you have the O. So the other piece we need then is, we know that this direction you become the X. So we need an else statement that will do the opposite of that, and we'll actually say you become the, so computer is equal to the X, and the human is equal to O. So all that does then is flip those, and so now we're going to return the values that are in computer and human. So we can return multiple values. And so wherever that gets called, it's going to return those values back. Well, moving on, we know we need to create a board, so a 9-square board. And we want those all to be empty to start with. So we're going to define a function called new board. And so this is simply going to create a new board. And so board is going to equal, and here's our list function again with the square brackets. We're going to create a list, and now we're going to put items in there. And so for square in range and so here we have to go get the value that we created up there, number of squares. So notice we could artificially change this. We could make a 4x4 board. It wouldn't work like what we've used before. Bless you, by the way. So now we've created a for loop for the number of squares and board dot append, and each one of them then we're going to put in the value that's in empty. So we've created this, and now we're just filling it with empty pieces. And then we're going to return that. Text here, chunk. All right. So then we're going to return board. So this will pass that function back in. So the next piece, we created the board. We want to actually display it on the screen. And so again, I'm going to copy this out just so I don't have to deal with all the characters in it. And it's nothing more than a set of print statements. And what those print statements do, if we look here on the display board, is it tabs from position to position. So the value in 0, 1, 2, 3, 4, 5, 6. So when we start this out, when it runs this, those are all empty. We've created them as an empty value or a blank. And so you can actually try this. So you could say, all right, instead of that main function, because we don't have a main function, what if I just run display board? And you can try those functions out. Now, it's not going to do anything, so what we really have to do is actually run new board first, and then run display board. So you'll see that, but we can do those in steps. But this just creates that blank board. Well, here is where it gets a little trickier. And so where it gets trickier is we have to come up with what are legal moves to play. And so you don't want to play on a square that's already existing. So if it's already got a valid an X or an O in it, you can't do that. So only those that have empty squares are available as a legal move. So we're going to define legal moves. And it's going to take in the value of board. And so I'm going to triple quote it. So finding legal moves to play. And so we're going to actually create another list called move. And we created a blank one, and then we're going to use our for loop again. For square in range. And remember that even though we're creating a 3 by 3 square, to the computer it's just a linear list from 0 to 8 or 9 positions. So we're just going to do that from the value in number squares. So it's going to run this 9 times. So if board in each position as we work our way through is equal to empty, then we're going to add it to our list. So we're going to use that append. So moves dot append, and then we're going to put in the value in there of square. So this is just creating a list of those moves that we can use. And then we're going to do a return, and we're going to return that list that we created back wherever it is. So now you know all the pieces that you can move. The hardest one in here is how do we tell the computer whether it's a winning move or not? The computer only sees a list from 0 to 8, and so we have to figure out if we've won or if we've tied, but we know that there's only a certain number of ways that you can win. So we're going to create something we're going to happily call winner, that's going to take in the value of board. And this one's going to be used to determine if you won. And so we're going to create a function or a value here called ways to win. And we're going to set up a tuple. So we've used lists, we've used tuples. In this case, we're not going to change it, so it's going to be the same. And so we just need to think about all the different ways that you could win in that square. So sometimes it's easier to create that out on a sheet of paper, those numbers. And so we know that if you have across the top all 3, so if I had 0, 1, 2, you would be a winner. So in this case, we just create a list of every way that we could win. Well, it happens to be this. Save me a little typing here. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8 different combinations that we can win. So those are every different possibility that you can win with. Well, now that we've done this piece, though, so we've looked at it and we said, all right, well, those are all the ways you can win. We need to do something with it. So now we need to determine if you really have won or not. So we created a list of all the ways to win. And so for row in ways to win. So now we're just creating a for loop that's going to check and see if all of those are empty. So the first piece here. So if board, so we get the values that are in that board list. And so if board row 0 is equal to board row 1 equals equal to board row 2 and not equal to empty, so we're just checking to see if any of these conditions happen to be true. And if that is, we say, yep, are you returning, and we return a value for winner. But we also want an if statement. So if empty, not in board. So in other words, what this says is we filled up all of the spots. And if we filled up all the spots and we didn't have any winning conditions, we know that we somehow tied. So we're going to return tie. So we have two conditions in there, and we can check against both of them. All right, so a couple more steps, and we can actually play our game. So now we know how to see if we won. We know who goes first. We need to get a move out of the human, though. And so it doesn't matter whether you go first or whether you go last or second. We need to get your move. The computer move we're going to figure out, and it's going to do automatically. So we need to find one for human move. And so this is going to take the values of board, that list for board, and it takes in computer and human. So the X and the O. And again, you can use that triple quote. Get the move from the human. And so we're going to get a value called legal. And we're going to pull that from legal moves. So we want to know that. And again, we're going to use that none value. So move equals none. So we're going to fake our way in. So the correct way, if we're really doing structured code, we would ask the input from the user once. We would then run our loop and ask it again. But we know we can force that loop to run if we start out with a negative that it's always going to run. So while move not in legal, move equals, and here we use that function up there, ask number. And so we're going to pass in, what square do you want to move 0 through 8. So you're telling them what they're going to do. And then we pass in the value of 0 for the low. We know it's not going to be higher than that. And the value for num squares. So you're passing in 0 to 8. You could hard code it, but this just gives us a way if you did want to change it or make something, it is easier to change. So if move not in legal, so now you're checking to see if it's a legal move, print, please enter a square that isn't occupied. You could even do a print statement here. That is a foolish move. Taunt your player a little more. And then we're going to return that value in move. So the human part's pretty easy. We're asking for a value. We check to see if it's a legal move. Not too tough. The computer, though, this is where it gets a little more interesting. So I'm going to copy this line just because I'm going to use almost all of it here. So I'm going to define a function now that I'm going to call computer move. But it's still going to take the board and the values we have for who is what. Now, here's where it gets kind of ugly. The computer is really not very smart. The computer can only do what we tell it to do. And so we have to figure out a strategy to figure out how to get the computer to understand and to move. So this board, since we're going to change it up a little bit, we're going to make a copy of it to use. So I'm going to say board equals board bracket colon bracket. So what we're doing is we're trying to make a copy of this because we don't want to destroy what we have. So the thing that we have to do, though, is we have to think about what are the best moves. So what's the best square on the entire board to move to? If we're playing tic-tac-toe against a little kid, where do we always go first? Which one gives us a little bit of strategic advantage? That center always gives us the advantage, right? So we're going to create what we're going to call best moves. And we're going to make a list then of the best moves we could possibly do. And we're going to search through that list then to see if any of those work. So we know that 4 is our absolute best move. That's the center of the board. Well, usually we then maybe go to the diagonals, so we could go 0, 2, 6, 8, 1, 3, 5, 7. So we have all our moves. We've just put them in order of what we think are the best moves. So the computer is always going to try those moves in that order. Not very fancy now that you look at it. And now we could even have some bragging. So print, I am taking the best spot available. And then you could actually have it print out whatever spot they're going to take. But so we also want to see if a couple of other things. So just going down that list, are we going to be able to stop somebody from winning? No. So we're going to have to figure out a couple of pieces. And one of those is, if I can win, I want to take that move. So the first choice is going to be for me to win. So I am going to run all the possibilities, and by putting my squares in different places to see if I win. The way we do that, and the reason we created that copy of that list then, of all the board, is because by doing this, we're going to actually set up and move a square in, check it, and see if that works. Otherwise, we're going to revert back. So we're going to do that all in this big for loop. So for move in legal moves, because again, we're only going to check those moves that are legal. So we're going to go through and check these one at a time. So if winner So this does something a little different. And so one of the things you're going to see is we're going to try a couple things through there, and we also have multiple returns. So because they're in an if statements, only one of them is going to return. So once it hits that return, it's going to exit out of this function. So our first piece then is going to check, do any of our moves create a winning situation? If they do, immediately we're going to stop our function and return back to the mainline program. If none of those work, then we're going to have to wipe out all the moves we did. And start over again. So in other words, this line takes that move we just attempted and reverses it. So it's like an undo. So this part says this is how we're going to create a winning scenario. Well, the other piece in tic-tac-toe is defense. So if I can't win, so this is a block, so it's going to work really very similarly. So now our blocking function, so we're taking the legal moves, we're trying out what the humans can do. So notice that difference. And so we're trying to see what value would let the humans win. If we find one, then that becomes our next move. So that's what we're trying to do with that one. So if neither of these work, so we can neither win nor tie, we don't have to do either one of those options, then we're just going to say, we're going to go up to those best moves we created, so our pre-canned scenario, and we're going to try that one. And so we're going to say for move in, so we're looking through that best moves list, and we're looking for one that is available. So here we're comparing it to what's in legal moves. And then we're going to return that move. So notice there we actually now have 3 different possible returns out of one function, depending on the scenario. So that function could return here, could return here, or could return here. So that's a little confusing. We don't have to have just one function or one return at the end. We can shortcut. So if it returns here, this code never runs. If we determine that we can win somehow, this code gets shortcutted out and it doesn't ever run. So other languages you can do similar things out of other code. Probably the closest way to this is like a break function in a loop where you break out and come back around. So we need a couple more functions to finish out our list, and one of them is pretty easy. So we're going to define the next turn function. So the next turn function takes in a value, and really all this does is switch turns. And it's just an if statement. So if turn is equal to X, return O, else, since we only have 2 possibilities, we're going to return X. So whatever value we bring in, it's just going to flip it. That's all that does. So if we bring in an X, it's going to return an O. If we bring in an O, it's going to return an X. So the last piece we have to do is we have to congratulate the winner. So the winner function really says we're going to get, let me move some lines down so we can see. So I'm going to define congrat winner. So this is going to take in a couple of things. So the winner and computer human. So this function doesn't know who's won. It's just getting in a little bit of information. So we're going to go chunk, 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 and put in our triple quote. If I do this correctly, it'd help. Chunk. So this one just congratulates a winner. So if the winner is equal to or not equal to tie, we can do that. And we're going to print. So it's either going to print an X or an O, or a computer or human, and it's going to print the winner. So you're just going to create a little function here that's going to say who won. Else, so if somebody didn't win, then obviously we have a tie. And so you could print it's a tie. So those are your two values. So the other thing you can do is then print in, you could add all kinds of other things. So you could put an else statement or an if and an else statement. So if the winner equals computer, and this is what we have in the book, is it says, you know, the computer gloats. The computer gloats. So you could do that. Not necessarily an integral part to the game, but it kind of adds some of that character to it. And notice, because this one doesn't return any function back, we don't need that return at all. So we just end our function. So we're almost there. We have one last piece. So remember down here we said we're going to call this function, and we're going to call a function to main. So if we're going to call main, we need to probably build the main function. And so we're going to define main. So a couple of things it's going to do really quickly. It's going to use the display, bless you. So it's going to display the instructions. And it's going to pass computer and human into pieces. It's going to automatically be, by default, it's going to say turn equals X. So remember, we have a function that flips back and forth, but by default we usually start with X. And so now we need to create a new board, so we're going to say board equals our function of new board. So now we've run that function. And then we need to display it. So we're going to display and we're going to pass that new board in. So all this does is figure out who starts and gets the new board created that's empty and displays it. So now we want to create this game to run several times. And so we need to actually create, those should all be indented, my bad. So we want this game to run until somebody wins. So we're going to put the game then in a loop. So while not winner, so as long as we haven't declared a winner, this loop is going to function. And so if turn is equal to human, then the move, we're going to set a function is equal to human move, and we're going to pass in the board and human. And board so if it's not the human's turn then we have to do the computer turn. And very similar, so move equal computer move, so it's calling our computer move function, and we're passing in board, computer, and human. We then run the function board move. So at the end of that, so whether it's an if or either it's a human or the computer, we're going to display the new board because now something has changed on it. We're we're going to call then the turn function. So that just flips the x's and the y's. So we pass in what the value is currently, so it'll either flip. Then we have, if a winner has been decided, then we're going to call the winner function. So winner board. And then we're going to call that congrat function. So all those are pieces we put inside the main. So this is the most complicated program by far that we've looked at. But when we start breaking it down into pieces, it's probably a little easier. Because I don't need to know, if I'm the coder, I don't need to know how somebody did the computer move. I just need to be able to call it down here and say, all right, so, yep, the computer's got to move. So it gives us that level of abstraction. So the main program's really easy. The main is only this. We run the main function. So let's run this and see what happens, and see if it will create a tic-tac-toe board. And so that display board function, that's what this creates. So we've created a game. So in this case, I'm going to say I do not require the first move. So that calls our yes-no function. And I went ahead and I let the computer move. And from that list of best moves, it's always going to go to that center. So where will I move? I'm going to choose position 0. And the computer goes, well, I don't know where else to move. I'm going to look on my list of functions. So I need to find the right number down here to block him now. So number 6. So I'm going to see what happens if I put in a move that's already done. So if I put in 0, square's already occupied, foolish human. Choose another. And so now I created, and I did this on purpose here. I went here. Clearly a bad move, but the computer then takes that and says, you won. And then it runs through its list of, I predicted I am the superior human, blah, 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 blah. So if we're able to beat the computer, you would see that we would get a slightly different response. So let me see if we can run it again. Do you require the first move? No. No, actually I do. And so now it shows me that blank board. I'm going to pick 4. Then I'm going to apparently pick 1, 2, 3, 0, 1, 2, 4, whatever it is. Nope. So, and if we get to a tie here, which we should pretty soon, so 1, and then it'll say it's a tie. So it goes through all those steps. So this is the most complicated code we've seen. So make sure you look at it. Those functions are a great way to break up our coding. And so we're going to start doing those more, and we can reuse those. So that's the best part is, once we've created a function like ask yes, no, we don't need to redo it every game. We can just go, yep, I'm going to run this function ask yes, no. So a couple of things about your assignment this week. So your assignment, so you're going to recreate the Guess My Number program from Chapter 3. Great. You don't have to build the game from scratch. Guess where you can go? I go over here to Course Documents, and I download this zip file, and that zip file gives me a list of programs. I have to extract it all, and I go to Chapter 3, and I say, all right, I want, whatever it is, Guess My Number. I'm going to edit that. And so now I have the program created that I'm going to modify. So this program, you need to do a couple of things. So make sure you've put your name in the top of it. you are going to take this program and you are going to break it into a set of functions. So one of them that I will tell you that we generally don't do, so generally these things like the imports, we leave those up here. So imports are going to stay where they're at. But how far you break this down into functions, so the first thing I would do is I would say, what's going to be in my main? How am I going to break this into functions? So I know I'm going to have a main function that's going to get called. So comment out everything you want to do. So call to the main. Well, if I'm going to have a call to it, I need to have a main function. And so you can start breaking this down into what functions you're going to have. So maybe you break it down into a couple pieces where you have set the initial values is a function. Maybe a introduction or display instructions is a function. So you can break this down into multiple functions. So if we did display functions, we could create, so we're going to say define, really easy, and maybe we just call it instructions. And that one's an easy one to do because generally your instructions, so you're going to define a function called instructions. And in this case, maybe this is all we have for instructions. We don't return a value, and we know that this creates a function to display instructions. And then you could do the triple quote if you wanted to do it that way. This is a function to display So you could do that really easy. So you're just going to break this up into sections, and then you're going to have to make it work. The hardest part of this, depending on how far you break it apart, is that passing of variables from function to function. So it's going to take some trial and effort. It's going to take you a little tears, probably not. But this one we're taking, again, existing code. You do not have to recreate this game. If you have a better way to play the game or have some other ideas, add them in there. Make it fun, make it exciting, make it interesting. So you can add in your own comments. You can change it however you'd like to.